everyone, I am Aarti Sharma. I have done my master from the NIT Jalandhar. So today we will discuss the concept of the salt hydrolysis. So before starting any topic, first we have to clear our why. Why we need to study this? What is the purpose behind to study this? Okay. So basically salt hydrolysis is used to calculate the pH of a solution of a particular salt. Okay. So basically salt hydrolysis is used to calculate the pH of solution of a particular salt. Okay. Let's start the topic. So when acid reacts with the base, it forms the salt and the water. So this reaction is the neutralization reaction. I hope you know. So when acid react with the base, it form salt and the water. So this reaction is known as the neutralization reaction. So neutralization reaction only occur when all amount of acid is consumed with the base and to form the salt and the water. So this reaction is known as the neutralization reaction. Basically neutralization means when acid completely react with the base and to form salt. Okay. So let's take an example. So best example is the when HCl is react with the NaOH. HCl is the acid, strong acid, and NaOH is the strong base. So they both react together and they form salt. What is salt here? NaCl and water. Okay. So from now you can observe this salt contain two types of ion. The first one is the positive ions, that is Na plus, and the second one is the negative ion, that is Cl negative, chlorides ion. So okay. So this is the salt. When the salt undergo hydrolysis, that means when NaCl react with the water, it produce some acid solution and the basic solution. Okay, that means this NaCl that contain Na positive ions and the Cl negative ions, and this H2O, it contain H positive ions and the OH negative ions. So as you all know that positive attract with the negative and this negative attract with this positive. So when this positive react with this negative, it form NaOH, that is the base. And when this Cl react with this H positive and it form the HCl, that is the acid. So this process is known as the salt hydrolysis. That basically means when salt undergo hydrolysis and form the acidic and the basic solution, and this whole process known as the salt hydrolysis. Okay, we revise this topic, we revise this again. So when acid react with the base, it form the salt and the water. This reaction is known as the neutralization reaction. So what does neutralization means? That when all amount of acid is completely react with the base and form the salt. So this reaction is known as the neutralization reaction. So when this salt that undergo hydrolysis and it produce some acidic solution and the basic solution, and this whole process known as the salt hydrolysis. Okay. So on the basis of acid and base, there are four types of salt that we study today. So on the basis of different type of acid and base, we have four kind of salts are there. The first one is the salt of strong acid and strong base. Second one is the salt of strong acid and weak base. Third one is the salt of weak acid with strong base, and the fourth one is the salt of weak acid with the weak base. So these four type of salts are there. Today we will discuss only two type of salt, that is strong acid and the strong base, and the weak acid and the strong base. Okay, so before starting this topic, first we take some little idea about what is acid and the base. Okay, so first we study about the acid. What is the acid? Acids are basically those which can release H positive ions in its aqueous solution. That means acids release H positive ion in its aqueous solution. Okay, so we classify acid into two categories. That one is the strong acid and another one is the weak acid. What is strong acid? Strong acid, from this name we can also say that those acids which are completely ionized in water and release maximum number of H positive ions. Okay, so ma'am, strong acid are those acids which can completely ionize in water and release maximum number of H positive ions. So what are the weak acid? Weak acid are those acids which cannot completely ionize and it release less number of H positive ions. So okay, so from the example we can clear the concept. So let's take an example of the strong acid and the weak acid. So lots of example of the strong acid, like this H2SO4 is strong acid, HCl, HBr, etc. What are the weak acid? Example of these are the CH3COH acetic acid, HCOH, H2CO3. These are the weak acid. So let's take an example of the strong acid. If we take H2SO4, it releases 2H plus ion and SO4 2 negative ions. So if we take 100 molecules of H2SO4, so this is a strong acid. Strong acid basically means which can completely ionize. That means from 100 molecule of H2SO4, 100 mole of H plus are released. That means 100 moles of H ion release. Okay, so if we take an example of the weak acid basically means the CH3COOH, it convert into CH3COO negative and the H plus ions. If we take 100 molecule of this weak acid, but as you guys know that what are the weak acid cannot completely ionize and it releases less number of H positive. That means from that 100 molecule of this acetic acid, only 40 to 50 molecule can give the H plus ions in the solution. Okay, so what are the difference between the strong acid and the weak acid? So strong acid basically means which produce large number of H positive ion in its solution. And what are the weak acid? Weak acid basically means which produce less amount of the H positive ions. Okay, so now let's discuss the concept of the base. So base basically means which release OH negative ions in its aqueous solution. In the same manner, we can classify base into two categories. That one is the strong base and another one is the weak base. Strong base are those bases which can completely ionize in water and they release large number of OH negative ions. Okay, so base are those which release OH negative ions. So what are the strong base? Strong bases are those bases which can completely ionize in water and release maximum number of OH negative ions. And what are those? And the weak bases are those bases which cannot completely ionize in water and it release less number of OH negative ions in the solution. Okay, so for example, strong bases are mostly alkali and the alkaline earth metal. Basically, most of the hydroxide of alkali and alkaline earth metal are the strong bases except beryllium and the magnesium. Okay, so what are the weak bases? Weak bases, example like zinc hydroxide, copper hydroxide, etc. Okay, so you have to remember that what are the strong acid, what are the weak acid, and in the same manner you have to remember that strong base and the weak base. Okay, so let's move further. So let's discuss our first point, that is the strong acid and the strong base. Salt of the strong acid and the strong base. So what are the strong acids? For example, let's take an example of strong acid, that is HCl. What is the example of the strong base? That is the first basically hydroxide of alkali and the alkaline earth metal are the strong base. So let's take NaOH. Okay, when they react together, they form NaCl and water. So this reaction is similar to the neutralization reaction, right? When acid react with the base, it form the salt and the water, and this reaction is known as the neutralization reaction. That means it does not undergo hydrolysis. That means it does not undergo hydrolysis. So the overall solution become neutral. Okay, so the overall solution become the neutral. So as you know, when the pH is equal to the 7, that means the solution is the neutral. And when pH is less than 7, that means the solution is the acidic. And when pH is greater than 7, that means our solution is basic. So in case of neutral solution, what we have, that pH is equal to the 7. That means in case of strong acid and strong base, it form the salt, and this reaction is the neutralization reactions. So for this reaction, the solution become the neutral. Okay. Okay. So let's take another salt. Weak acid and the strong base. So weak acid is the CH3COOH and strong base, that is the NaOH. When they react together, they form the salt, that is the CH3COO and H2O. Okay, so remember that the salt are the good electrolyte. That means it's break into its ion. So this salt CH3CONa break into its ion CH3COO negative and this Na positive. Okay. So when this salt undergo hydrolysis, so what you can observe that this is when this undergo hydrolysis, this cannot undergo hydrolysis because it is a strong base. When these ions react with the water, it react with the OH negative part of the water and they combine together and they form the NaOH. NaOH is the strong base. That means it completely dissociate into its ion and it release OH negative ion. So this reaction continuously going on. Okay, so it does not undergo hydrolysis. So only the salt can undergo hydrolysis. That means if the CH3COO negative react with the water, it form the CH3COOH and the OH negative ions. So as you know that this H2O, it contains H positive and the OH negative ions, and these negative ions react with the H plus ion and they form the CH3COOH and it release OH negative ions. So from this reaction you can also say that ma'am, in this reaction OH ion is produced. That means our solution become the basic solution, and that also means that pH is greater than, for the basic solution pH is greater than 7. Okay, so this is the weak acid. So here equilibrium is established. That is the KH. What is KH? That H is for the hydrolysis. Hydrolysis basically means how much amount of salt undergo hydrolysis. Okay, so this is the KH. K for the constant, H for the hydrolysis. So this is the hydrolysis constant of this salt. Okay, H for the hydrolysis, K for the constant, and this is the salt. So this is the KH is known as the hydrolysis constant of salt. Okay, that means KH is equal to the reactant of product divided by the reactant, sorry, so KH is equal to the concentration of product by concentration of reactant. Okay, this equation is the first equation, and now there are actually 2-3 reactions that I have to mention. So first I write the reaction, that another reaction is the hydrolysis of water. That means when H2 undergo hydrolysis, it release H positive ions and the OH negative ions. For this we can write the KW. That means this is the ionic product of water. Ionic product of water. Okay, so KW, that is equal to the concentration of the product and by the concentration of the reactant. But as you know, the concentration of water is constant. Okay, so we can write like this. So this equation is the second equation. Okay, so now a third reaction is also there. That is the when CH3COOH, when acid dissociate into its ions, that means when acid dissociate into CH3COO negative and the H plus ion. Here also an equilibrium is established, that is known as the Ka. That means the dissociation constant of the acid. So A for the acid, K for the constant, and weak acid is dissociate here. That means that Ka is the dissociation constant of acid. Okay, so how we can write that Ka is equal to the concentration of this product by the concentration of the reactant. Okay. So this equation is the third equation. Okay, so you can say that so what we have to do, like we multiply the equation first and the third. Okay, so I can erase this. So multiply equation first and the third. What you can get that KH into Ka. Okay, what is the value of KH? That is the CH3COOH and the concentration of OH negative ions, and divide by the concentration of this. Okay, multiply to the, what is the value of Ka? Here the value of Ka, that is the CH3COO negative ion, and divide by okay. So what you can observe from here, that this cancel out with this portion and this concentration will cancel out this. So KH and Ka equal to the concentration of H positive ions and the concentration of the OH negative ions. And as you know from this equation second, that the concentration of H positive ions and the concentration of OH negative ions, that is equal to the Kw. So we can replace this concentration by the Kw. Okay. So we can rearrange the equation and we can also write that Kh is equal to Kw by Ka. Okay. Okay. So this is the main formula. We have to remember that. So value of Kw is 10 की power minus 14 at 25 degrees Celsius, and in questions they are given to the value of Ka, so we can easily calculate the value of Kh. Okay, so what is the next step? So I can write this formula here. That Kh is equal to Kw by Ke. Okay. So when this salt undergo hydrolysis, and this constant is known as the hydrolysis constant of the salt, that is equal to the CH3COOH and the OH negative ions. So at time t is equal to 0, we have only the reactant. That means its concentration is C. There is no formation of product over here. That means the 0, 0. At time t, that means at equilibrium, but we can observe that. Okay, so what you can observe that C minus CH and the CH product is formed. What does that mean? So, in starting, the concentration of the reactant is C and the product does not form 0, 0. At some time, what you can observe that some of the reactant that is converted into product. So 1 mole of this ions of salt give the 1 mole of weak acid. That means 1 mole undergo hydrolysis. So what is left over here? The 1 minus H. Okay. So what is the concentrations in starting? That is the C, and H mole undergo hydrolysis after some time. So what is the formation of product? That is the CH and the CH. Or what is left over here? That means C minus CH. Okay. So we can say that KH is equal to the CH concentration of product by the concentration of the reactant, that is C minus CH. So here you can, what we have, that C square H square divided by C minus CH. Okay, so from here we can take C out of the bracket, and what we have, that CH square by C 1 minus H. This cancel out from here, so the formula is CH square and 1 minus H. So hydrolysis, H for the hydrolysis. So its value is very small. That means we can say that in place of this 1 minus H, we can write CH square by 1. Okay. So what is the final term that we have? That is KH is equal to the CH square. So we can also rewrite the equation like this, that H is equal to the KH by C and under root this volume, because here the H square na, so this square is written like this. Okay. This is the second most important formula. So we can write over here that H is equal to the under root of KH by C. Okay. So as you know that when H positive ions react with this OH negative ions, it produces H2O. Okay. So what is the concentration of this OH here? That is the CH. Here the H plus. Know that the Kw, that is equal to the concentration of H positive and the OH negative ions. So what is the concentration here for OH negative ion? That is the CH. Okay. Kw as it is, H plus is also as it is. So what you can write, when we calculate the concentration of this H positive, it is equal to the Kw by the CH. And we have the value of H here. This value, we can put this value of H here. So Kw divided by C, and what is the value of H? That is the under the root of KH by C. As you know that ma'am, we also have the value of this KH. What is the value? That is the Kw by Ka. We can also write here Kw by Ka into C. To solve this reaction, what we have, under the root of Kw into Ka divided by C. This value is for the calculate the concentration of this H plus ion. This is also very important formula, and the one formula is also here. H plus is equal to the under the root of Kw Ka divided by C. So the formula, what we have to do, we have to calculate the pH. So the formula of calculation of pH is equal to the minus log and the concentration of H positive ions. So what is the so this H positive value put here and to calculate the pH of the solution. I hope it is clear. pH of this, what? Weak acid and the strong base. Okay. So what we have here, let's combine this. So when we take the weak salt of the weak acid and the strong base, weak acid undergo hydrolysis. Okay. So we have three kind of reaction over here. In first reaction, salt undergo hydrolysis. and that hydrolysis constant, that is the KH, that is the hydrolysis constant of the salt. Then next reaction, that is the ionic product of water, we have to calculate. That is equal to the H positive ions and the OH negative ions, and the constant ionic product, that is equal to the KW. Now we had write the last reaction, that is for the dissociation constant of the acid. That means acid dissociates into its ion, and the equilibrium for this reaction, that is the Ka. Okay. From these all equations, we have to calculate this value of KH and the H hydrolysis, and we have calculate the value of this H positive ions, and from that H positive ions we have to calculate the pH also. Okay. So to better understand this concept, we take some numerical, that is the find degree of hydrolysis and the hydrolysis constant of salt and the value of pH of salt and given value here, that is the Kw is equal to 10 की power minus 14 at 25 degrees Celsius, and concentration is the 10 की power minus 2 molar, and the value of Ka is also given, that is the 10 की power minus 4. So you have to calculate degree of hydrolysis, that means H. H basically means how much amount of salt undergo hydrolysis, and this KH hydrolysis constant of the salt, and to calculate the pH of this salt. So first we have to calculate the KH. So what is the formula of KH? That KH is equal to the KW by Ka. So KW, value of KW, that is equal to 10 की power minus 14, and what is the value of Ka? That is 10 की power minus 4. So that equal to the 10 की power minus 10. Okay. So first part we solve. Now from this part we can also calculate this H, because now we have the value of KH. Okay. So KH by C. What is the value of KH? That we have to calculate. That is a 10 की power minus 10. And what is the value of concentration? That is given 10 की power minus 2. So 10 की power minus 8. And to solve this root, it comes 10 की power minus 4. Now the last part is also remaining, but before calculate the value of pH, we have to calculate the value of this H plus ion. So the formula of this H plus, calculation of this H plus, that is equal to the KW Ka divided by C. What is the value of Kw? 10 की power minus 14. What is the value of Ka? That is 10 की power minus 4. And what is the value of the concentration? 10 की power minus 2. And this is under the root. Okay. So to solve this, the value becomes equal to 10 की power minus 16 under the root of 10 की power minus 16. And to solve this root, the value is 10 की power minus 8. So the value of H positive, that is equal to the 10 की power minus 8. So from that we can easily calculate the value of the pH. What is the formula of calculation of the pH? That pH is equal to minus of log and the concentration of these H positive ions. So I can write here, that is equal to the minus of log and the concentration of H positive ions. What are the value of these H positive ions? That is the minus 8, 10 की power minus 8. This minus come here, and minus minus plus 8 is also coming here, and log 10. What is the value of log 10? log 10 that is equal to the 1. So pH becomes equal to the 8. That means this solution is the basic solution. Okay. Why this is basic? Because pH is greater than 7. So this solution is the basic solution. Okay. So